All right, so let's now look at a topic that's called composition of functions here. So this is another understanding, quite fundamental understanding about function, but it is strictly required that we must learn this lesson. We must learn about this lesson after you have learned about all the basics about functions, including that all the graphical properties of a function. Okay, and in my style of teaching, I highly recommend learning this video lesson here, learning this lesson after you have also been familiar with doing some of the more advanced type of function evaluation problems, meaning I'm specifically looking at you should be able to now evaluate a function at an input that other than a numerical value at an input being an expression, being able to evaluate and simplify a function at a given input, but being an expression instead of a numerical value. Okay, but other than that, without the worry about what exactly it means by the composition of functions, we will get to that. Okay, so that's now, for now, it's just the title of our discussion topic here, and let's get into it. All right, so let me now introduce the idea as following, and it's not an example yet, it's not a formal example, but I have to demonstrate through a problem. Okay, so in this problem here, let me promote the idea as following. How about we're gonna start out having two functions. So let f of t be t squared minus t. Okay, so t is the variable of this function f. So this function f is a rule. It has the rule says takes the input. So in this function notation that you have already been comfortable with, that we've been fully understanding, then in this notation right here, the variable that's inside the parentheses here is going to be the inputs, the main inputs of our function. So the rule here is regarded as the f function. So the rule for this function says we're going to square every input and subtract the input value again from what that is. Okay. So that's function f. Now, and I'm also going to give another function g. And for this function g, it takes the input variable is named x. 3x minus 2. Okay, 3x minus 2. All right. So it's the function f of x, g of x here. The rule says it takes the inputs x multiplied with 3. Okay, whatever inputs x here is multiplied with 3 and minus 2. It's a different rule. So two functions, two different rules. Okay, so now let me look at the following problem. I want to evaluate from these two given functions. Let's evaluate and see if, as I'm writing down along right here, see if we can understand that. Evaluate and simplify. Okay. But I'm going to promote the following problem. Okay, so f. Okay, but instead of f of 1, f of 2, we've been doing that so fluently, so I'm not going to get into that. I'm going to do, how about f of 3x minus 2. This is the reason why I say I highly recommend viewing this video lesson after you have seen another video lesson of mine that was done before this lesson right here, before this lecture right here, where I introduced the more advanced type of problem where we evaluate function at an input being an expression. And this is one of those problems there. Okay, so, but if in case you haven't seen that lesson, it still should be okay to carry through this. Everything here is the inputs. Okay, all that idea. The idea about function, and so in function notation, then whatever inside of our, just like what we have already learned, whatever inside of our parentheses is here. That's why I'm underlining this with squiggling line right here. The entire 3x minus 2 is an expression instead of a numerical value. So in our understanding at this point, doing f of 1 is easy. I don't need to mention about that. Doing f of 0 is easy. You can just go see 1 square minus 1. Because the rule said so, the input, okay, is square minus the input. The input square minus the input. And so in that idea, now no longer being, without being a specific number, but being a an expression, then my work here will turn out to be, from this rule it says 3x minus 2 square minus 3x minus 2. Okay, and then if you've watched that lesson of mine where I introduced these type of problems specifically, then I put in a lot more detailed explanation. Okay, as well as also my habits, my style of how I always keep the input in parentheses here. Okay, and then of course from here we simplified it out. We FOIL out the square right here, and then we simplify down the term. Okay, so to simplify down, the foiling work for the square here is going to give me, because we can think of that 3x minus 2 all square as a 3x minus 2 times 3x minus 2. Okay, and then we're going to start doing the foiling. If somewhere here and there from your past course, from your previous course, that you have picked up some fast trick to quickly foil this, that's a big plus for you, but it's not a requirement in order for you to understand this lesson right here. Okay, and then so doing that, you should be ending up with, so allow me to write that final result here. It's going to be a 9x squared, okay, and minus a 12x and plus 4. Okay, so all that there is the end simplified result for this perfect square right here after foiling. Okay, and then here we're going to subtract the 3x minus 2 according to whatever it was from the previous step. And then I'm still on my way to come down to the final simplified expression. Okay, and so here what I'm looking at now is going to be 9x squared minus 12x plus 4. I have just now taken away the parentheses without worrying about sign change, because in front of my parentheses for the first group right here there was a positive sign. But now for the next group right here, since due to that negative sign in front of the parentheses, I'm going to have to switch sign for every term here. So positive 3x here becomes minus 3x. Minus 2 right here becomes plus 2. And now no more parentheses, and we are ready for collecting like terms and combining like terms, or cancel out opposite terms if there are any. Okay, so 9x is the only one term, 9x squared I meant. Okay, and then these two, the minus 12x and the minus 3x, they are like terms, so they become 15 minus 15x, and the 4, the plus 4 and the plus 2, they are like terms, so the plus 6. And this is our final simplified expression. And again, this emphasizes that I have had a particular lesson specifically showing people how to handle these kind of problems right here. So basically it's a function that we evaluate at an input being other than a number, being an expression. Okay, but so the intention of this lesson here particularly is not to aim at repeating these kind of problems. Okay, but this is what I'm doing. Now, if you're looking back at the beginning point here a little more, if we're looking back at the beginning point a little more, that f of 3x minus 2 right here, wait a minute, does that 3x minus 2 look a little familiar? Yes, here in this expression right here, the 3x minus 2, the entire underlying one here is playing the role of the inputs. The whole 3x minus 2 is playing in the role of the inputs. That's why it's like this. Okay, but this is, now I'm just pointing out what I further recognized about this entire expression from beginning. Okay, because the way we're doing here is just a basic, just a standard way of how we evaluate our function f at this given expression. Okay, but now wait a minute, 3x minus 2, this is indeed g of x was previously defined as 3x minus 2. This is just on some extra space right here that I just want to mention. 3x minus 2 was previously, even before we get into this problem, it was previously defined as a g of x, as another rule. An expression is a lot of time used as a rule of a function. Okay, and so that means there's a further impact, there's a further consequence upon realizing that the entire 3x minus 2 was previously defined as a function. Okay, so upon realizing that, Now allow me to quickly swing on the other board space right there. So that means this f of 3x minus 2 legally equals to f of, but now instead of calling that 3x minus 2, it's even there's even a shorter name for saying that f of g of x, f of g of x. So this is what we recognize right here. This is what we recognized. Okay, we recognize that. Okay, this thing that we saw in the beginning of our promoting problem, this, wait a minute, it's actually recognized, it should have been recognized as f of g of x, or in case we didn't, now we realize that. Okay, that's f of g of x. So the way how I say it, this whole thing right here, we can say this f of, see, f of, and then inside of that it's an expression. A function is also an expression. Okay, so f of g of x. Okay, f of g of x. All right, so now that means alternatively, now sadly I'm a little bit running out of space right here, but so that means alternatively, instead of writing this form, now you're going to start being introduced to the kind of problem where instead of writing things like this, I could have done this from the beginning. I want you to evaluate f of g of x. All right, so f of g of x really will become this, because g of x itself is this expression itself. Okay, g of x itself is that expression itself right there. And then from that point on, we're gonna start applying our experience from doing those kind of problems where we evaluate a function at a given input being an expression, and then we proceed on. And so we're not going to end up with a numerical answer, but instead we're ending up with a simplified final expression. Okay, and notice x here is the variable, the input variable inside of my g function. My function f in the beginning, when it was written down, it used the t variable, but now the name of the variable is not the important part. I'm saying it out loud here. The name of the variable is not the important part. What's important is the rule of what to do with that input variable. Okay? What's important is the rule. So the f function here, the function f here, what's important about that? It's the rule. The rule says we square the inputs minus t. Minus the input again. So sometimes you can call the input the t variable, sometimes we call the inputs the x variable, but the rule is what makes it the function itself. Okay? And so that's why, so now here I substitute the entire g of x, the entire expression g of x, okay, for t. All right, and then that consequently becomes the function at this expression 3x minus 2, right there. And then we proceeded on and substitute that input, that designated input, into our rule of the function f. Okay, and so in that way, that's how it works right there. So now we realize I pointed out this problem at start. I pointed out simply just that problem at start, and now we realize that this problem, hey, wait a minute, the whole 3x minus 2 was indeed that function that was previously defined to be g of x. So in other words, this problem here could have been written from the beginning. The way how we're writing this could have come from another way of writing that. Hey, we evaluate and simplified f of g of x. Okay, the way of what we're doing here. Okay, now alternatively, I can do the following. Logically, we can do the following. F of g of x, just like that understanding we have had when we were still doing those problems where we evaluated a function at a given expression, then in the way how I'm seeing this, if I'm talking about an alternative way of how I'm doing the problem. Now, once I become fluent with where an input is and where an output is, I see g as the input of f. And so the rule for f, so f really is the main function, and g is just, think of that as some expression inside being given as the input for f. So we can go g of x, the whole expression, square, because the rule says we square the expression. Okay, and then we square the input, and then we're going to subtract the input again. That's how it is. We can lay it down things like that, and skipping that step of writing this as the f of 3x minus 2. And then in the next step, now g of x was previously defined to be the 3x minus 2. Okay, so now I can write it as so g of x now is the 3x minus 2. So now that consequently becomes the square, and minus the g of x here is the 3x minus 2, and now we're coming back to that point earlier that we've had. All right, so and in the end we're gonna continue spending out steps here to simplify down the expression here. So that's a different way of how we are organizing the problem. Okay, so now ladies and gentlemen, you are now being introduced to the idea. So it takes that exact idea about how we evaluate a function at a given expression, but now we're going to step into a further step. We take a function and evaluate that at a function. So a function becomes the input of a function. Okay, some function becomes the input of another function, or some function takes the input as another function. That's what it is. Some function takes the inputs being another function, being a function. Doesn't have to be the different as well. We will get to that. Okay, and so now once you're starting to see where I'm going along that way, let me promote another problem still with these two previously defined functions. And with this same instruction tree here. Now how about g of f of t? G of f of t. All right, so now have a moment, slow it down. You can pause the video if you want to. Have a moment to understand clearly the instruction of the expression here. G is a function. Okay, that was previously defined. The rule for g here is 3x minus 2. 3 times the inputs, 3 times the inputs, minus 2. So in this notation right here, what do I see? Primarily, g here is the function. Okay, but then there comes that larger pair of parentheses here. Everything inside, even though it appears to be another function, but that's okay as long as the whole expression here stays inside a pair of parentheses. Okay, then the whole thing here is the function notation. So that means this entire expression f of t is the input. All right. It's the input. So in that way, now let me align with how I did that in the earlier quick little problem I brought up. So in that way, I recognize that, hey, this input was previously defined. This function f of t here now being the input of g of x. Okay, but in the end, f of t was previously defined as t squared minus t. So now consequently, I have my right, I have my legal right, my mathematical right to rewrite this as a g, the function g, but takes input as the expression t squared minus t. Okay, my function g, but takes that input t squared minus t. Okay, takes that function g takes that expression t squared minus t as its input. I repeat that in 3 different times in 3 different ways like that. Okay, and now seeing this clearly written down right here, then we have a clear instruction of what to do. So this is the inputs, this is the inputs, the really written out form of the input. This is just the general expression of the input. Okay, so now in order to evaluate that, we need to put things like this. And now the rule of the function g. So mainly, like I said again, the main function here is the g right there, the one that's outside of the largest expression right there. Okay, so now the rule of the function g that we primarily focus to is saying that we're gonna, for every input, for whatever the inputs, we're gonna multiply 3 to the input and minus 2. So the input is currently t squared minus t. That's the input. And so you have seen my style quite often enough now. I always put input substitution inside the parentheses. Okay? 3 times the input, the whole input. So parentheses is for grouping. We group the whole t squared minus t as one group, one expression, one thing, okay? And then we multiply 3 with that whole input, and then we minus 2. And now the work with the usual mathematical operations come out right here. We need to first distribute, okay? So the distributive law now says we're looking at 3t squared, okay, minus 3t. I just left for myself a little bit too narrow space right there. Okay, so now I'm looking at 3t squared minus t. There was no negative sign, so nothing, no sign change needs to happen here. Okay, minus 3t indeed. Okay, and then I'm gonna additionally minus 2. That's everything came out from the. So at this point that we came to this point due to the rule of the function. And now once we've had that successful setup right there, then we're gonna, from this point on, we're on our way to simplify that overall expression. So we already ended up with an expression in terms of t, and then here we're moving on to simplify that. Okay, and so now this is what I'm seeing right here. This is going to be 3t squared, and I just now realized that was pretty at its simplified form already, because none of the term here is a like term with any other one. So we are quite at this final simplified expression. Okay, so there you go. That's again another problem where I'm looking at a function taking inputs, okay, as taking another function as its input there. Okay, or it's a function of the input being another function. All right, so now let's formulate all of that idea right here. So from this point on, and now I'm erasing this, but allow me to still beat around the bush with this quick little g of f right here. So g of f, just like how I have done in the earlier problem, I could have also written this as, once I recognize this to be just some expression to be the input, then the rule of this, immediately you can think of that. I'm talking about alternatively, an alternative way of thinking. The rule of g says for whatever input that is, being the f of t. Okay, so f of t is the input. We're going to multiply that with 3. Okay, and then minus 2. See, the rule of the function g says whatever the input here, see, if it's only one simple variable, it's simple. But here it's just being a little more complicated. But it takes the whole input, multiply with 3, minus 2. That's the rule. Okay, and then from that point on, now we can start understanding that as 3 times with all that t squared minus t minus 2. And we're going back to that simplification work there. It's an alternative way of thinking it. Okay, thinking through it. And there are so many ways of understanding it. It's what matters. Okay, understanding that this is the input, the whole, whatever the function we put inside here, that's the input. And then this here represents a rule. The rule applies on that input. Okay, so now we've had enough working around with these introduction problem right here. So now, ladies and gentlemen, allow me to say this. Both of those, so the f of g of x that we have done, we put g as the input of f. I mean, as a quick notation, g as input, okay, of f. And then that's one form. Then we can have g of f of t that we just now finished. Okay. In this case right here, f is as input of g. Okay, f as input of g. But either one of these two cases, either that case or this case right here, these two cases right here, this is what it called, any one of this is generally regarded as, this is the composition. Okay, the composition of f and g. And I don't even need to write the variable's name right here. Just f is a rule on its own, g is a rule on its own. They could be even the same function right there, but that's what the composition of the two functions is. You have two ways of doing composition. You can put g as the input of f, or you can put f as the input of g. But any one of these is called the composition of f and g right there. Okay, so but that's just a general way of indicating it. That's just a general way of indicating it. So now this way is just a general description right here. It's not too specific. So usually people don't use that way of saying it that much. People don't mention that term too often. But now this is more specific right here. Okay, so in this way, the way how it reads, this one here clearly it reads, the way how it reads, okay, f of g of x. Just straight out from, as an impact from our understanding about how we read function notation. F of, see, if it was f of t, because the input here is just one simple variable's name, one simple letter, but now no longer a letter, it's what? F of g, f of g, f of g, that's how we read it. And then, but then further, g is a function of x, so f of g of x. Spend a moment to think of that logic I was trying to explain right there. So the way how it reads right here, f of g, just like here it's f of t, but see, I mentioned this a little bit earlier. The name of the variable here is not the important one. It can also be f of x. Then here, everything here is x squared minus x. It's f of w, and it's w squared minus w. So here's f of g. Okay, g squared minus g. Okay, but g itself is another function of x. So that together, as a whole thing blended together, is f of g of x. All right, so that's how it reads right here. And so now, so precisely, this is the way how it reads, but this thing right here is called, this one right here is called, that's how we read it, but now the whole picture over here is called f composed. Okay, because f is the outside function and the input is the inside. I mentioned that earlier, and I had to erase that line. So this whole notation right here is called f composed with the g of x. Okay, this is the name right here. So I shouldn't write this in red ink, making it more confusing. Okay, that symbol right here, it's called the f is composed with the g of x. All right, so similarly in the way how we have already understood that, then this symbol, you see the way it reads, this symbol right here, the way it reads, this is g, it's a function g, g of f of t. The innermost variable here is t, but I could have also used that x here as well. So the whole thing here reads g of f of t. Okay, so because just like this, if it was just simply one x right here, it's g of, because that's the standard function notation that we're reading it, we're learning to read it. And anyone viewing this video should have been familiar with how we read that already. So now it reads g of x here. So here, instead of x, it's f of t. So g of, but not x, g of f of t. All right, so that's how that's how we read that symbol. That's how we read that symbol. And then really what it means, and really what it's called right here, when people see that symbol and talking to each other and refer about it, okay, then it's called, this symbol is called, very similar to the one we've had earlier, it's called, but this time, see, look at there are two rows here. Here, f is the main function. See, f of that, so f is the main function. G, even though being another function, but being related to f, g is the input. And so that's why it's called f composed with g. Okay. I have heard some older textbooks also use the term composed of g right here. So here in the more modern day, it say F composed with G. But I've also heard some professors, some earlier generations of professors, they also call that F composed of G. Okay, and so in that way, this one right here, back to what I was saying. So now it's not F of, it's G of, right? So here is when we're talking to somebody, we and mention about the symbol, we say it's G. It's called G composed, right? With F, okay? G composed with F for short, or to be a little more specific, F of T, okay? Because of that T indication right there. All right, and then yes, so just like that, some professors of the earlier generations also call this G composed of F. Yeah, but it's two opposite the involvement. Okay. All right. So in the end, let's even put it further. So you've now had the idea. I haven't put in any formal example yet. Okay. But now we're gonna just keep exploring notation. So a little further about notations here. On this board of mine, all right, so now this symbol, the way it reads is clear, really clear, right? The way it reads is F of, because the parentheses is here and it's a function, we know F is a function, so F of G. And disregarding, like I said, usually for short, we can ignore that in the most inputs right here, because it can be X, it can be whatever, but mainly it's a function G in here as well. Okay, so mainly it's F of G, F of G, F of G, F of G, F of G. Okay, so now here's a F of G. So, ladies and gentlemen, I introduced for you F circle G. The circle really came from the word of, but we erased out the word, the letter F. So now F circle G right here. Okay, as a notation, F circle G, and then the final input. Because see, the work I've done earlier with this right here, this final X right here that's the final inputs. And when I mean the final inputs, because see, remember this problem, when at the really end it was a 9x squared something minus a 15x and plus 6, something like that. Okay, so the final, because in the end we created a brand new function. And then that final function here is in terms of x right here. Okay, so now, just now I explained F of G produced this F of, it became a circle, okay, because I erased away that F, that little F letter in our word of. So F of G, okay, but then add the final input variable here being x. All right, so F of G, that's F circle G from now on. It's another symbol over here. See, it's a means anytime we see this, that symbol means F of G. That's how it reads right there. So keep that circle in mind. Read it off. So F of G. Okay, and then that final input right there is in here. Okay. So in that way, now you can start applying your understanding already, even though it's not even an example, because this is basic enough. It's just beating around with the expression and playing around with the notation right here. So that on my earlier board, I brought up this problem. So now in the way how I read it, how we read it, and I shouldn't use yes, it's equal sign in terms of notation. Okay, but formally I would like to indicate that the way we read it, this reads G of, okay, G of F. That's primarily what we should target at. Okay. G of f. F is inside the parentheses. It reached G of f of t. And that t is the final expression right there. So f of t is one thing, but mainly it's the bigger picture is G of f. Okay? And so here, just like that, G of f. And now, creatively, mathematician, and this was not my invention of this kind of symbol. Some much earlier generation of mathematicians invented that. Okay, and it passed down. That way I'm explaining now was once explained to me by one of my favorite professors. Okay, so f of g, and then with the final input here, expectedly. See, let's check it out again. See, when we were doing that g of t right there. Okay, so G of f right here. So G of f is the symbol, but when we actually did that, it was 3 times the t squared minus t minus 2. Okay, and then in the end we ended up with that with a final expression in terms of the t variable. And so now I so-called that it's a final input. I should have called that input variable. Okay, so the final input variable here is the t. Put it there. It's not a multiplication. It's not a multiplication here. It's not a multiplication here. Okay? All right. Anyone viewing this lesson, this lecture is expected to be at the college algebra level or the pre-calculus level. This is where we really dive into this. You might have seen this here and there, but allow it to give you the most detailed understanding, because you will carry this on and bring that to your higher level courses. Okay? Don't look down to this understanding. It will help you remember this better, much better, because I believe you may have seen this before prior to learning this course, but at some point it was in the way it was, in the way it should have been, when it was introduced prior to pre-calculus, your majority at that time wasn't high enough, so professors tend to simplify it down. Okay? It's not their fault. It's just the way it needs to be. And then now when you are seeing the whole thing again, it is now the right time and the right place, okay, to look at everything in a really in-depth understanding, so that you will have that and keep that with you and bring that to the later courses, your higher courses later. Okay, and so that's why now, see, formally we read G of f here. G of f. And I erase out that f right there. Now it's become G circle f. The final input here, I just now convince everybody, there is a t. And that's why, see, the t here is the final input variable. All right, so that's why I put that in an extra parentheses. So G of f is a final function and adds the input variable t, or you can also say of t. You could have also say of x here, okay? But too many of, and so we say G of f or G circle f at t. All right, that's now the symbol for that. So this is just notation, okay? This one right here is just a notation. It's just a matter of notation, the symbolic form. Okay, and what it means, this here means f of g of x. This means g of f of t. That's what it means right there. All right, and so now at this point, we are ready for doing some formal example. All right, so here comes our example 1 right here. After you have been fluent enough with what the symbol means and what the idea is, we're now starting out with example 1. Okay, so all right, let's now start out with how about given f of x be, I have an x squared plus 1, okay, and further I have a second function, g of x. So these are all given functions right here. And here I'm looking at the square root of x minus 2. Okay? Square root of x minus 2. Okay. So now, once we've had that, let's evaluate. Okay? Evaluate and simplify. Evaluate and simplify. Part A. All right, part A. And so now allow me to start using the formal notation. These notations right here. And I should have mentioned that. These are now the formal and the quite standard notations you are seeing throughout all mathematical algebra textbooks out there, okay, in the world. Okay, f of g, or f circle g, f or g circle f. This is f of g, this is g of f. Okay, and then I still have the meanings right here. Okay, so now let's evaluate. So I aim right at letting everybody be comfortable with the symbol. All right, so right there, part A of the example. Let's read. Let's evaluate and simplify f circle g. F circle g. All right, so now as I'm going through each example, I will show you how my thought process is so that you can recognize and use that with you and apply that for your case right there if it works. Okay, but I may go about a few, up to part B, part D, part F or something like that, but I will never be able to cover all kinds of examples out there. Okay, so I want you to learn and click on the generalities and be able to apply that on your own case right there. So now the generality that you should first see, I'm using that symbol f circle g. And how I explained that earlier, it means f of g. Read it out. And I try to explain where that symbol came from, so it now hopefully helps. Okay, it now hopefully helps you to have a clear understanding of what that tells you to do. So this came from f, but we took away the letter f, so really it's f of g. Okay, sometimes you hear professors say f circle g. Yes, understandable, because the word of we have taken away that letter f right there. That's why it's f circle g. But now when you call that f circle g for too long, then you're gonna start forgetting where it came from and what it means. So it's gonna become a deadly nightmare for students. I have seen it became such a deadly nightmare for some students who came to my class from a previous course with somebody else, with some professor, some other professor that keeps saying it's f circle g. Completely understandable, but then as a consequence, the student had that unclear understanding, that or had a really hard time telling who's inside and who's the outside. Okay, and so here just call it f of g, and it's circle g, completely fine, but remind yourself that that circle means it came from the word of right there. F of g, f of g, and the final variable here is expected to be the x. So this is what it means. Write this down first in line. I'm not only showing how to get the problem done, but I'm also showing the safe habits to get your problem done successfully when you're doing it on your own completely. F of g, reading it out loud, at x. That's why x here is the final input. F of g of x. That's how we're writing it down. All right, and so now once we have arrived at this point right here, then things will become a lot easier to breathe. It brings back to that kind of problem where I promoted the idea earlier, where I introduced the idea earlier. You got two options to handle this. One way is to see, this is the way how I more normally have done that. F of, because I normally more comfortably see this g of x as what's previously defined here, square root of x minus 2. Okay, so, or how about I could have just written that here. That's how this is how I do it normally. Okay, that's how I do it normally. And then from that point, now that brings back our experience from the earlier lecture that I've been saying. I had a specific video lesson about how we proceed to those advanced kind of problems where we evaluate a function. So the main function here is f, but we're evaluating this function at some advanced, at some input being an expression. No longer an f of 1 or an f of 0 or an f of 5 or something like that. No longer a specific value being the input, but it's a given expression. And that's the kind of problem. Okay, so you feel free to exit out of this lesson and view my other video lecture anytime that if you want to strengthen out that skill where I specifically explain about all of that, the tips and tricks there. Okay, but now once we realize the meaning of this, we're going to continue, we're going to carry out further. Okay, so now I'm looking at, so the rule of, so now mainly the function that we need to worry about, the rule says, it's the function f here, the rule says for every input, we're going to square the input in plus 1. That's the rule. Okay, so now for every input, currently we use inputs x square root of x minus 2. So for this input, for every input, we're going to square the input and plus 1. Okay, and so in that way, now this square here is outside of the square root, so it will cancel perfectly with the square root and leaves behind just x minus 2 without the square root, and then plus 1. Okay, and now I can take away the parentheses here without worrying about sign changes. And so now I'm looking at x minus 2 plus 1, and these two are like terms. And we can combine them. So in the end, it came down to be, I'm a little short at space, so allow me to write x minus 1. Okay. When you are fluent enough, you can immediately skip the parentheses right here already. But it just, see, in my style, I move really slow so that everybody can catch every details, and I'm trying to maintain every step of mine is consistent with how I have been doing it. Okay, so I'm grouping it here just to indicate that this whole group, x minus 2, is only come out being whatever the end result for this square here. The whole x plus 1 aside from that group get carried over from the previous step. That's why I'm still using parentheses here. There were students questioning me about that already. Why did I have to go too much? But that's the idea. Well, in the role of a teacher, of a professor, I just want to tear it down to every single little detail so that my students can be ensured to follow in every step. Okay, so this is your final simplified expression. See, this is here we evaluate. The whole work is to evaluate. See, this right here is evaluating, and then we know what to do with that. So right here is the end of the evaluation. And further, once we finish evaluating, we realize that we hit into an expression. So we're going to continue simplifying it further. And now here's one more time how it's convinced us right here. The final expression, it's just making things perfectly consistent with each other. This final expression is in terms of x. That's why there was that x outside of the f circle g thingy. I'm also using that term f circle g, but I have already explained. So in my mind, f circle g is more primarily the f of g. Okay, all right. So this is, but this start right here, this start point is just my style of starting point. Okay, I mean from this bridge, from this step to here. I should have pointed my finger to here. Okay, forget about what I said here. It will always, this f circle g will always equal this. But from here to the first step, okay, let me make a star right there with that first step. Okay, somebody else, if you're not comfortable with writing things this way, you can do the following. This is an alternative style of presenting your work. It's not my style that I'm doing comfortably, but you can pick that up here and there and learn it. And you can even do that on your own style as long as you keep things organized and get yourself on the right track in every single step. So I'm gonna, in a separate column, right from that star right here. So you can think of that as how about, see, from right here, f of g. The rule of f says for every input, we're going to square the input. And then plus 1. Square every input and plus 1. The inputs in this symbol, read, g. It's not a number, and it's an abstract looking expression, but you can do the following. G of x, see, group that, square, that's one input. See, the rule of the function f says we square the inputs, with the inputs being g of x, we square the inputs plus 1. That doesn't hurt. That's logically correct and entirely legal. Okay, so that's instead of this. And then from that point on, now we realize, hey, g of x was previously defined as square root of x minus 2. So still inside of that bracket, indicating it's a group, indicating it was a substitution I had earlier. Now g of x is substituted by x minus 2 all square plus 1. And now these two steps become the same. Okay, so we kind of branch out in our thoughts a little bit, and then eventually it's going to meet at one point. Okay, so either way, I'm all fine with that. Okay, and being the role of the teacher or the instructor, right? At some point, if you are learning directly with me through a class right here, you will have to turn in your written work for me. If you're presenting your work this way or that way, either way is going to be good. Okay, and think about just a little bit side talk about your future courses. If you are taking a higher courses, your professor there shouldn't even have to worry about how you present these, because in your future courses, when you see this symbol and be fluent enough, you are even allowed to jump all the way to this step. This step can legally become your starting point at a higher course. Here we're just getting to know it and learn to get into the in-depth understanding. Okay, and so that is the reason why, you know, write it down as many steps as you can. Okay, show your work, have some good documentation of your work right there. Okay, but that's how we have evaluated and simplified problem A right there. All right, so here we go. Let's head out for part B right there. Okay. All right, so part B is another quite simple one. So how about G, circle F, but now we should formally read that as G of F, okay, of X. Okay, the final expression here is in terms of X. Okay, so let's find out. All right, so this will automatically be understood as G is the outside and inside of that, so G is the main rule that we should be now focusing to. The main rule is here. For every input, we're going to subtract 2 first and take the square root. So G is the main rule. But then we're going to take f of x inside of that. So instead of G of 1, G of 2, G of negative 2, we're doing G of f of x. Okay, that's what it is. And so now once we've had that, and set down that clear, crystal clear foundation for ourselves, now we can advance to the next step easily. Now that equals, okay, that means, how about one more step right here? That means this is G of, now I'm going to take that x squared plus 1 inside. And this is where that brings us back to the kind of problems you have seen in my separate video lessons prior to this, supposedly. Okay, that about where I show how we can evaluate a function at a given expression. All right, and so now from that point on, with this quite clear instruction, that becomes, so the rule of G says for every input, we're going to, I yelled it out loud earlier, for every input, we're going to subtract 2 first, because all of that here is inside the square root. Okay, so it's just the order of operation. So for every input, we're going to subtract 2 first, and then whatever that comes out, we're going to take the final square root. Okay, so now that means for every input, in this case, we run right into that input being x squared plus 1. We're going to minus 2. For every input, we're going to minus 2. That's why I'm even writing this down. I'm writing that in that order of operation. The input comes down first, and what to do first thing with the input, and then what to do after. Take the square root. All right, so now I've had, this is the evaluation. This is where we finished evaluating the function G at this specific given input being an expression x squared plus 1. All right, And so now once we have had that done, then now in the next step we are going to proceed further into simplifying it. So inside my square root there, I see we can take away the parentheses without worrying about sign changes, because in front of the parentheses is there and still inside the square root. Everything right now inside of the square root. It's a positive sign. So x squared plus 1 and minus 2. And now we can, so everything is still inside the square root. We can combine like terms, okay, to shorten it down, to simplify it down. So in the square root, in the same square root, we have x squared but minus 1. And now all of a sudden we realize we're ready. I mean, we're done. It's the simplified final expression. All right, that's how we can do it. All right, that's how we can do it. All right, so now that's enough with part B of the example. Let's now even challenge ourselves a little more. So the idea of a function, a composition of two functions. Okay, a function composed of another function, or a function composed with another function. Let's even see how far these problems, these challenges can reach. Okay. So now let me also, as I write it down and finish writing down the problem right here, I want you to pause the video if you can. Okay. Because it never hurts to pause the video. Pause the video to think of what I'm asking you to do. F circle, or F of all right, so hopefully you've had enough moments, because you could have paused your video. Okay. Hopefully you've had enough time to think through. So once again, read it out loud. What does this say? Okay, F circle G is one way, but more formally, F of F. And as we say things like that, as we say it like that, it will click better. F of F at the final input X. Let's not be too worried about that, but see, this is how it is. F of F. So we put that function F inside of itself. All right. But now, no big deal, no problem. No problem. F of F. See, and so this final input right here is sort of like in the innermost parentheses is right there. That's why it's the final input. So now, in this way of reading the function notation, then I'm seeing that the main function here is F, and then it takes. So here's how I recommend my style would click a little better, even better for myself right there over the years doing this. F of, so what's the rule for F itself right here? Don't worry about this F, but the rule for F itself is x squared plus 1. That's the rule. So now it's F of x squared plus 1. F of x squared plus 1. All right, so now that means here I'm looking at so in the next step, we're looking at a clear indication. The rule for F says for every input, we're going to square that. And plus 1, square the input in plus 1. So now it's going to be x squared plus 1. But this x squared plus 1 is already the input. Okay, we take the function itself as its own input. And then plus 1. That's how it is. All right, and so now at this point, the next step we should be taking. So this is the end point of evaluation. And now in the next step, we're going to go ahead and simplify. Okay, we're going to simplify our expression here. So it takes some foiling work right here. Okay, so all right, so now sadly I have to erase this on my other board right here to use this space here as a scratch work space. A space for scratch work. Okay, so let's look at that x squared plus 1, but in parentheses all square right here. This is thought of as, and again, as I said, if you have learned it somewhere here and there from your previous course that there was a fast trick of how to quickly FOIL this out, go with that. Okay, this class is not about to teach you again how to do those kind of things. I mean, if you've had that, good for you. If you haven't had it, not a problem. You can still do that, but maybe just a little bit the longer time than the other people. But I'm still going to stick with the longer solution because it's more standard for everyone. This square here is the same as x plus 1 multiplied with itself. It's a product of two identical factors. Okay, and so now we're going to FOIL. Okay, FOIL, FOIL, FOIL. So x squared times x squared consequently gives me an x to the fourth. X squared times a 1 consequently gives me an x squared. X squared, I mean 1 times x squared gives me another x squared term. So these are two like terms already. And 1 times 1 is 1. So now we can combine these two like terms. Our final simplified product is x to the fourth plus 2x squared plus 1. Okay, this is a final simplified expression for this square right here, but only for that square. All right, but now I'm ready to bring that back into our problem, our current step of the problem on the other board. All right, so now let's look at that. So now whatever the work I've done up there to that final expression is only a substitution for this, is only a replacement for this perfect square here in the current step. Everything outside from that square, everything else aside from that square, gotta get carried over from this current step. So now that means I'm gonna produce a parentheses. It's just my style, again, as I have explained this here and there earlier already. So x to the fourth plus 2x squared plus 1. I'm still using parentheses because all that here indicates it's a substitution, it's a replacement for that only term in the first step. So everything else get carried over. That's what I meant. All right, and so now we can safely take away the parentheses here. We take away the parentheses here. And so now, due to the fact that it's just positive sign in front of this group right here, so taking away parentheses here makes no difference, right? Makes no sign changes or anything like that. And then we plus 1. So in the end, okay, so in the end, this is the following, so these two are like terms. Okay, so we're looking at x to the fourth plus 2x squared plus 1 plus 1. And just like I pointed out earlier, these two are like terms like that. So now we can combine them. So tentatively, this is supposedly the next step like that. Plus 2. Okay, so 1 plus 1 was plus 2. So this is our final simplified expression. And it's in terms of x again. And that's why it's consistent with this particular problem. All right, 3 problems so far, and you keep being exposed to different problems, different situations like that. I wouldn't say it's necessarily harder for this problem. I'm not saying that the challenge here is rising. I'm just saying that it's just maybe it throws you in a situation that you may be a little bit unfamiliar, but that's all. But the way to get there is still simple, I hope. Okay? All right, and if it's not simple at this moment, you might think because I'm the professor doing it, I'm the instructor doing it, you can get to that one day. Okay? It may not come immediately today because you're still learning. Tomorrow it will get better. The day after tomorrow it will get better again, and it will keep getting better. Be patient and constantly working on it. Okay? So now let's look at another trying problem, another problem to work at. All right, so let's look at part D of the example. So you have seen, you saw where I was going in part C. So you can kind of make a prediction of where I'm heading into for this particular problem. So how about G circle G? But now I would prefer that you read this. G of G. G of G. All right, G of G. And so now that means, well, the meaning of that is G outside and then taking the input, inside being itself again. So the input for this function G, so primarily G is the main function, and then the inputs we're taking for that function G is G itself. So in the end, it's all that advanced kind of problem where we're evaluating a function at an input being an expression. Okay, so I don't mean to promote that particular lecture right there, but that particular lecture, there was a reason why I decided to teach that as a separate lesson right there, because it really helps anyone into, focus your attention into having your attention into that kind of specific details because it's used quite often here in this lesson and many other lessons. Okay, so now this means we're looking at g at, and then now the g of x itself is here. Okay, x minus 2 is the rule for the g of x inside. All right, so now at this point we are ready to move on right here. So the rule of g says for every input we're going to subtract 2 from it, and then we're going to take an overall square root. So now for every input we're going to subtract 2 and take the square root. See, sometimes here and there I'm coming up with a slightly different creative thing right there to keep people stay focused on what we always have to keep like that. So see, whatever inputs, I'm going to subtract 2 and then comes out, put it in a square root. That's the rule for g. But now that whatever input I was saying, it's a square root being in there. All right, it's a square root being in there. All right, so at this point we have done successfully the evaluation work. We have evaluated our function g at an input being g itself. Okay, but now that's not enough. We need to advance further and simplify that expression. Okay, so now it's square root. Okay, now I can here safely remove that or take away those 2 parentheses here because the sign in front is a positive sign again and still inside that big square root. So now I'm looking at another square root level right there, and then minus 2. Notice this 2 here is outside of that inner root, so don't combine these 2. So it's a silly reminder, but it did happen to some of the students I've seen when classes are face-to-face. Some students of mine cancel these, combine like terms with these, but they are in two different worlds. And ladies and gentlemen, this is about the dead end of our problem. We're about at its most simplified form already. Okay, nothing else can be done. Okay, and so that's how we evaluated and simplified the g of g, right there. Okay, so it all depends on the way how our function is set up. All right, and now let's head out for example 2, where we are going to be continuing to practice more on composition of functions. And we should be now throughout example 2 able to put it into more challenging problems. Okay, so let me now call that example 2. All right, so now we're again given with 3 functions. So how about f of x here is an x squared minus 4x plus 3. Okay, and that we have a function f of x, and then we have g of x given to be, so how about a 2x minus 5, okay, and then we have a third function, h of x, defined to be, okay, so we have 3 functions. And so in other problems there could be up to 5 or 6 functions. There are a lot of these. So about a 1 over x. All right, so once we have these functions given, again the instruction of the problem is as following. Okay, we want to evaluate and simplify. All right, evaluate and simplify. All right, so now here we go, part A. All right, so now I'm going to look for f, and really now I'm going to just simply pick any 2 of these functions, Okay, for now we have 3 functions given. I'm going to pick just any 2 of these functions. So how about as an improvised plan right here, how about f of h, okay, or f circle h of x. All right, so now this is more like just a repeated problem of the kind of problem we have seen, the kind of problems we have seen already in example 1 like that. Okay, so this means, so now I can start speeding up the pace a little bit because you have seen all of that explanation, okay, and all of that fundamental understanding. So now this means the same as, and I was saying it earlier, this was f of h. So h is the name of our function of one of our functions. F is the name of one of our functions, and g is also the name of one of our functions right here. So f of h, or f circle h. So now this is the way how we're writing it, f of h. So clearly I have to put h of x inside of f. I put the function h of x as the input to be substituted for the input of the function f of x. Okay, and so now in that case right here, now the rule for f here is saying for every input we're going to square the input and then subtract 4 times of the input and plus 3. That's just the rule of a function. So at this point, anyone learning about function should be fluent with the idea that, and really nail it down, a function is a rule. Okay, and so now in that way, once we see this clear indication and it's in proper standard function notation, then we can go ahead and proceed. So the rule says for h of x as the input right here, then I'm going to have, and h of x itself is a 1 over x function. So here my function is 1 over x as the input. But the rule says, the rule of f said that we're going to square each input. Okay, so there we go. My input in parentheses squared, and I'm going to subtract 4 times of the input, 1 over x. Just like that. But now instead of the simple x, it's going to be an expression, 1 over x. And that's why, again, I put that input in parentheses. So minus 4 times 1 over x and plus 3. So at this point right here, we are done with the evaluation step right here. But now let's continue to see if we can simplify this any further. So now 1 over x all square in parentheses is square. See, it's in the way how I used parentheses, and then it's indicating that this square here means 1 over x times 1 over x. Okay, so that's why 1 over x times 1 over x is now totally an 1 over x squared, and now I can I no longer need to use the parentheses there. And the minus 4 times 1 over x, it's a multiplication, but in the rule of multiplication with fractions here, then we just simply need to multiply that 4 with 1. So in the end, it's a minus 4 over x. So it looks now simpler. At least these two, in this terms right here with these two separate factors, now I put them in one fraction. And then plus 3, okay, and we can call that, we can already call this in the simplified final form. I mean, somebody can even go even further than that. We can make common denominator for that, but some instructors require that, some instructors don't. So technically at this point it is the final simplified expression of that, in the sense that there are no like terms to cancel. I mean, there are no like terms to combine, or there are no opposite terms to cancel, okay? But if you would like to put them all in one fraction by making a common denominator, you are welcome to do so. So if that's the case right here, then be aware that your final expression here can be even proceeded into one more step right here. This is an overall x squared, okay, and then this is 1 minus 4x plus 3x squared, okay. You can call that. That's also another way of writing your final expression right there, your final simplified expression. Okay, just different expressions instead of that. All right, so now that is the end of example 2, the end of part A of example 2. Okay, and the whole intention is to continue making students who learn this with me, or anyone viewing this lesson, to get more comfortable with the idea of composing two or more functions together. And I didn't even get to that point where we have done anything with beyond 2 functions being composed together yet. Okay, let's look at part B. All right, so how about another random pair right here? How about I'll pick H and I'll pick G right here. So how about H? I want to evaluate and simplify the H of G of X. All right. So now at this point, let's keep reminding ourselves, the circle here means of. So H of G, that's what it reads right there. So straight out from what we just read. So learn to read it out loud, or get for yourself into that habit of reading out loud maybe if you don't have an audience to hear you read out loud, read to yourself. It's h of g. Because doing that, it will align you with the next step being in proper step right here. H of g. Now you know how to set it up correctly. H of g. And that means now in this way of writing it, it shows clearly the role of h and the role of g right here. G is being in the role of the inputs. G is now regarded as an expression. G is the role represented by this expression. And it's now the inputs of h. So h is the main function, and g, the entire g, is the input. And that's why we're putting that inside of h. That's another way of saying it. We're putting g inside of h. Okay, g is being the input, being put, substituted in the variable of h. All right, so now in that way, the rule of h says which it's just 1 over x, 1 over every input provided. So that means here it's 1 over g, okay, and g is already this. Or we can remind ourselves a little further that h of g means h of 2x minus 5. How's that? I could have done this throughout my part B as well. And I could have done this throughout my earlier examples as well. Okay? And then now that means now in the rule of h, the rule of h says 1 over whatever input that is. Whatever input that is. 1 over, so now the input that is the entire 2x minus 5. All right. And then so 1 over 2x minus 5 is quite at its own simplified version already. So I can do nothing else better than just taking away the two parentheses here. So it's 1 over 2x minus 5. Okay, and that's our final simplified expression. All right, so we've made another composition of two functions, h and g, like that. Okay, so let's now look at part C of the example, and you can already start seeing how the pace of each one of these problems has become a lot faster. Okay, because now once you've had that, and I should emphasize it's not really that challenging and that complicated to do this kind of problem. Okay, quite simple as a matter of fact. So part C. All right, so I'm going to pick another pair right here. So how about g of f? Okay. And then at some point I'm going to run out of creativity to pick any of these two random pairs, and you can have your own fun time picking one function as the input of another one. Okay, so here it reads g of f. That means g is the main function. F is another function, but being regarded as, in its role here, the inputs of g. The inputs of g. Okay, so that means it's g of. Now f is this specific. Is written by the rule that's written by this specific formula right here, or expression right there. So that entire expression, x squared minus 4x plus 3, is written in here. Okay, and furthermore, you can also see that it's f of x, so that means this rule here, but we use the variable x, like that. We put it here. Okay, and so now that means now we're going to start evaluating it. We're going to evaluate the function g at this given expression. So the rule of g says whatever inputs of g, we're going to multiply that by 2 and minus 5 with the order of operations. And so now the input of g in this case is that entire is the entire expression x squared minus 4x plus 3 in terms of x, of course. So I'm going to take that input, and currently I have grouped it in parentheses. So 2 times with that input minus 5. 2 times of that input minus 5. And you can see that I always write down the inputs first, and then I start applying the rule on top of that, the rule of each particular function that we're working with here. I wrote down the inputs being the entire expression, and then I wrote the rule. That's why I grouped it. It would be the best idea that after I wrote down the inputs, I grouped that and then apply the rule on top of that. Okay, and so the rule said again 2 times every input minus 5. I wrote down the inputs, and then I wrote the rule around it. Okay, and then from that way it's going to start producing the operations for us. So here is a 2 multiplied with an entire group being grouped in parentheses here. So now it's time to take away parentheses. So we will multiply 2 for each of the term here, so that, and the 2 has no negative sign, it's just simply positive. So distributing it in, it's not going to change any sign for that. So it's 2x squared minus 8x plus 6. Okay, and so now parentheses were taken away, and then I'm going to subtract 5. So this part came out as part of the rule earlier. This came out just as a consequence of distributing that 2 like that. And now what I have now is, now we are ready for combining like terms. So 6 minus 5 is a 1 combined together. So 2x squared minus 8x plus 6. Okay. 2x squared minus 8x plus 6. All right, so that's how it works right there. And so now let's look in the same example right here. Let me bring up another problem right here. So you can see that any of these functions is a function that takes the input x right here, and takes the input x, but I did say earlier in my lesson here, in my lecture here, that the name of the input variable is not really that important. You can call that, I mean, the point is, it's the rule. For every input, for this function f, for example, every input, we're going to square the input minus 4 times the inputs plus 3. Okay, but the inputs, we can name that x, we can name that t, you can name that s, you can name that w, whatever. Okay, so I have a reason for saying this, for keep repeating that. So once in a while, let me remind you about this. So let me call that part D of the example. So I'm going to pick another pair of functions. So how about this time it's f circle g, okay? But now instead of x here, I'm going to call that, how about w? F circle g at w. Formally, f of g of w. Let me verbalize that again. F of g of w, or f of g, as usual, at w. So what it means here is that it's, as we said it out loud, f of g, yes, that makes clear sense enough, but the function g now is going to take variable, is going to take the w instead of, for its variable, for its input, instead of the usual x as defined here. But no matter whatever the input variable's name is, the rule of g remains the rule of g. The rule of f remains the rule of f. The rule of h remains the rule of h once they were defined. Okay, so in this way, the instruction now has become quite clear. It means it's going to be f. The expression that represent the expression that g represents is the 2x minus 5. But see, this was when this is x when we use x as the name of the input variable. But here we use w to be the name of the input variable. So just simply w replaces x. So that means here we're looking at 2w minus 5. I mean, it's simple. It's surprisingly a simple thing, but it can be also tricky for somebody. So that's why I have to mention this out. I mean, every single problem I'm pointing out here, I'm presenting here, came out from experience. I've taught someone here and there, and they face these kind of difficulties. So I just want, and forgive me if any of these video lectures are getting lengthy at some point, okay? But because I would like to show all experience I've seen as much as I can. So now apparently it's f of 2w minus 5, and that came from this. And then this came from understanding what it says here. All right, and so now in that way, once we set ourselves at this point and we are ready for the actual evaluation work right here, the main function is f. The main function is f. What we're inputting for that function f is the 2w minus 5. So 2w minus 5 as its role. It's the inputs. The whole thing here is the input for this rule. So the rule of f says for each input. So the input here is 2w minus 5. So for each input, we're going to square that. So for that input, I'm going to square that. See? And then the same inputs. Okay, we're going to subtract 4 times of that input. See, that's why I always write down in each step, I always write down the input first and write the rule applied on top of that. And then plus 5. All right. And so now in this way right here, we're going to start doing, at this point we have done evaluating the function f here at that specific input as an expression. But now let's spend some time on scratch work. I'm going to move over to the other board space there to do scratch work, but I would like to use my scratch work space to FOIL out this expression. Okay, so now on this board right here, 2w minus 5 square. Okay, again, my recommendation is to think of this as a 2w minus 5. It's the easiest way of thinking of that. Okay, but in case you already learned some faster technique, I'm all open to that. Okay, you're all open as long as you arrive at the correct simplified final expression for this. Okay, but allow me to teach in this lesson the method that's common to everyone. Okay, and so 2w times 2w gives me a 4w square. Okay, and then 2w times minus 5 gives me a minus 10w. Now minus 5 times 2w is another minus 10w, and then plus a 25 here for these two to multiply together. And now we have some like terms. So yes, we're going to finally arrive at 4w squared minus 20w plus 25. But this, ladies and gentlemen, is the final simplified expression, but only for the square, only on that square term. But now I can go back to my other board. So this square term, I have taken care of that square term on scratch work. So that means in my next step, this square term now can be replaced by, so I put parentheses again, 4w squared minus 20w plus 25. Okay, so that's in parentheses. Okay, and then now I'm going to minus 4 times 2w minus 5 and plus 5. Okay, and so now, as a matter of fact, here I can start rushing the step a little bit. In this step right here, I should have done distributing out that minus 4 for each term there. So how about, let me correct that as following. Okay, I apologize in case you already wrote down and had to erase something due to my sudden change right here. But the minus 4 times 2w is a minus 8w. Minus 4 times minus 5 is a plus 20. Okay, and so now in the next step we already, but I also need the other space right there to continue my step. All right, so, but before we move on to the other board right here, let's observe. So we have that trinomial, that 4w squared minus 20w plus 25 still being in parentheses. So in the next step, I am going to take away parentheses and we're going to start combining like terms. All right, so have a good look before I completely move over to the other board again. Okay. All right, and so now in my next step, and this is the formal work, it's not scratch work. So there was no negative sign in front of my group of parentheses from the previous step. So I can just simply take away the parentheses without worrying about sign changes. So 4w squared minus 20w plus 25 minus 8w plus 20 plus 25, I mean 5. Okay, and so now we have lots of like terms to combine right here. The minus 20w and the minus 8w will combine together. These three constant terms can all combine together. Okay, so now that makes it 4w squared minus 28w plus 50. So this is, ladies and gentlemen, the final, this is the final, okay, simplified expression. Okay, That's how I call that a lot of times, but in the end, that's just whatever the ending result of f of g at w. F of g at w. All right, so that's how it's done. That's how it's done. So let me still, put in a few more problems in this current example over here. All right, so part E here. So what about this time? I'm going to say f of g, but of h at x. All right, welcome aboard. The problem is starting to give more challenge for us right here. The problem here has started to give more challenge for us. We have three things together. It's not only two functions. Okay, so the circle things now starting from this problem on, I want you to start realizing, once you understand the idea about composing two functions together, or you understanding what a composition of two functions is, then we should not be limited to only two functions like f circle g or g circle f or f circle f or g circle h. Those I've been mentioning are only just two functions composed together, but now we can have even more functions composed together. Okay, and that's the reason why right from the beginning I already wrote down three functions, because times like this will come. Okay, so what does this mean? So stick with that way in order to understand what this means. Stick with that way how I've been explaining. And this over here means of. This circle over here means of. It came from of. Okay, so here's how it says. F of, just write in that order, reading from the left to the right, f of g. So f, anytime we're doing an of, so now g is in the parentheses. F of g, but then g is not just simply of x, okay? F of g of h. See, simply just stay from the left to the right and reading it from the left to the right. F of g of h. So another parentheses, h is inside of g. All right, and then at x, so that means h is a function of x. That's what it is, ladies and gentlemen. So simply it's just a matter of being patient, just a matter of patiently reading through from the left to the right, and we can go with a crazy sequence of f of g of h of a of b of c whatsoever. Okay, but in the end, it's a composition of functions can be more than two functions. All right, and there's no need to bring in examples with with composition of 5 or 6 functions. It's not impossible to do it. Just taking our time away. Not too practically. That's all. So just to give anyone viewing the lesson here a little bit taste of how it can grow beyond two functions composed together. Okay, so now that's the clear indication. So we have to really start breaking it down one by one. So from one by one, so now from the inside out, here's how I'm seeing it. H is this function 1 over x. The rule of h says 1 over x. Okay, so it really means f of g of 1 over x. F of g of 1 over x. That's what it is, because h of x from the inside out. And at this point, needless to mention, you could have realized that already. Anytime we're working with a composition of functions, we always, to really evaluate, we work things from the inside out. We tackle down right from the innermost function and then see that as an input. So the innermost function, see that as an input. Know what it is first, and then evaluate that into the outer function, and evaluate it whatever that is here for the even outer function. Okay, so that's why h of x from the most inside one right here, I'm going to look at that one and see that as the rule 1 over 1 over x. Okay, and then from there I'm going to look at from the inside out again, g of 1 over x. Let's look at that. Let's look at what it is. So my first composition happens inside of the function f. So here it's still f. But now let's do some composition. G, the rule for G says 2x minus 5, 2 of whatever input that is minus 5. Okay, so the input here currently is a 1 over x. So the rule for G says 2 times 1 over x minus 5. That's how I see it. Okay, that's how I see it. 2 times every input minus 5. And then yes, we're going to start simplifying this. Okay, I wrote this down just as a note here for anyone to know what to do. Go ahead and simplify this. So 2 times 1 over x is a 2 over x. That means now I'm just repeating this step right here, but with a more simplified version. So f of, so now 2 over x minus 5. Okay, and for as far as simplifying this g of 1 over x is this part in here. And as far as simplifying it, ending at this form with 2 terms is okay. Okay, but I would highly recommend to put these 2 terms, combine those 2 terms together in one fraction, in one rational expression. So now I would find common denominator, which is the skill that you should have learned and hopefully mastered by now from your previous course. But making common denominator and all that, my overall expression for this is going to be a 2 minus 5x over x. How's that? At least it's give me the expression that is in one fraction. Okay, and it's just one expression in one fraction. But now this is what's currently being the input for our function f. And the rule for f now is right there, x squared minus 4x plus 3. The square of every input minus 4 times of the same input plus 3. Okay, so now I'm going to move on to my other board and get things done right here. All right, so at this current point, we're looking at f of 2 minus 5x over x. Okay, and so in that way, now, as I said earlier, this entire 2 minus 5x all over x is the input. So now from what that input is, 2 minus 5x over x. The rule of the function f said that we're going to square every input and then minus 4 times of the input. So that same input again, 2 minus 5x over x. Okay, and now plus 3. That's the rule of the function f. Okay, and now we're going to start simplifying. Okay, now we're going to start simplifying. So now algebraically that expression becomes 2 minus 5x all square over x squared. Okay, minus, now I'm looking at, so minus 4 times 2 is a, well, I can still keep that minus here, but I'm putting that as an 8 minus 20x in my numerator over x, and then plus 3. All right, and now I'm going to, let's put it all into one fraction right here. So it gives me 2 minus 5x all square, okay, minus, now 8 minus 20x, but multiply with an additional x, okay, and then plus 3 x squared, and all that here is x squared. So by making common denominator, which is eventually an x squared. So again, the skill to how to find common denominator of 3 rational expressions, you should have learned that in your prerequisite course right there. But so now making this common denominator, this particular fraction in the middle, I need to multiply the numerator with x, and that's how I consequently ended up with 8 minus 20x times x. And then all of that is over an x squared, because x squared will be your final common denominator. And then 3 must multiply with x squared over x squared. And that's how I ended up with plus 3x squared all over one common denominator, x squared. And now let's do distributive law for this. Okay, and foiling out for that. Okay, and so I no longer have the space to do scratch work anymore. So allow me to assume that I can leave that for students of mine or viewers learning from this lesson to foil out on your own independent page with this. Okay, but your final FOIL product for this square should be the following. All right. So for that square, I'm looking at 4 minus 20x, okay, plus 25x squared. That's what happens, what will end up when once you have successfully FOILed and correctly FOILed. Okay, and now I'm going to multiply the x and at the same time distribute out that minus sign. So we're looking at minus 8x plus 20x squared, and then plus 3x squared. Okay, and all of that here is over x squared. All right, and so that's close to my last step right here. So in my next step, I'm just going to simply take the parentheses out, okay, and then combine like terms, and we should be able to arrive at our very final answer. Okay, so now in that way, I'm going to need to erase some of the steps above this so that I can continue from there. All right, so now from here, continuing our work right there, I'm going to look at, so there was a positive sign right here, so taking away the parentheses, it will not change the signs here. So it's 4 minus 20x plus 25x squared, okay, and then minus 8x plus 20x squared plus 3x squared, and all over x squared. All right, so one more step before we are completely done and simplified. These are all like terms, okay, with a little underline like that. These are like terms like that, okay, and I put the little overline like that, and then that was one lonely term. So now all together, okay, 20 plus 3, and then with a 25 right there, we're looking at 48x squared, okay, and then minus 28x, and then plus 4. All of that is over x squared. But now that is our most simplified expression, and this represents f of g of h. This is, ladies and gentlemen, the simplified answer for f of g of h. That's what it is. Okay. All right, so that is the end of our example 2 right there. All right. All right, so in this way, I'm still going to use the 3 functions from the example 2 that we just erased. Okay, but now I'm going to separately discuss about these functions, and then I'm going to promote some more. I'm going to introduce some more problems right here, but not as a new example yet. Okay, so how about we're going to let f of x be that x squared minus 4x plus 3, okay, and then g of x was the 2x minus 5, okay, and our h of x was that 1 over x. Is this 1 over x? So at this point, we have been doing all of that f of x. So I really hope at this point, because we have been doing all of those compositions. So at this point, I hope you have already formed into a routine that anytime you see this, f of g or f of something, right? And we have had a try before with this. Even switch this x to a different variables or a different thing right there instead of x right here, and then but now this reach f, and then we put g inside. I'm using the term inside, and then inside of g it comes that variable input, okay, and we work from the inside out. That's the order of the work right there. Okay, so let me now mention this kind of problem that to me it's easier than the one we've been working with. It's still all about the idea of composition of functions. Okay, to me it's maybe easier than the earlier one, but it could be a strange and tricky situation for somebody. Okay, and that's why over my time teaching it, I decided to put it after we have done the earlier kinds of problems in example 1 and 2, and now I'm going to mention this. Okay, I mean, it could be surprisingly easy for somebody, but it can also be challenging and tricky for somebody else. And that's why, and I have experienced more people facing challenges with this kind of function, this kind of problem I'm about to introduce here. So let me bring that up. See, if I ask you to a simple thing, just simply to evaluate, okay, and we don't even have to worry about simplified or anything like that. Evaluate. How about f circle g? So f of g of 1, f of g of 1. Okay, so this means just like what we have been seeing. See, I brought up that problem earlier throughout example 2 already. F of g and of w. Maybe I did not do the exact problem, but at least I was doing something similar like this. I changed that ending input right here. Instead of an x as how it appeared initially in each function here, I changed it to a w, and you can change that to an a or an m or whatsoever. Here I use a specific number. That will work too. Okay, so in how I did this, it was f of g, but g is taking inputs w. Let me remind you that. So now in that way we can take that as a generality, and then now we can apply that what we understand here. So this means, see, f of g, still that same exact thing that we've been doing, f of g, but now of 1, just like that, f of g of w. So now instead of being a w, it's now an actual number. I mean, we've been loving to work with specific number, but I don't know why for some of my students, when classes are face-to-face, when it's actually get them into an actual number, then for a situation like this, they actually back out. So here it goes. That's how we write it in the first line. Okay, and now how do we do this thing? Then I also mentioned this when we were still somewhere in example 2 earlier. Just work from the inside out. Just work from the inside out. So that means f of, but g of 1 right here means what? G of 1 means you're going to substitute 1. Now we have a specific number. Bingo, go for it. Because we can evaluate, we can actually do calculation. So it means 2 times 1 minus 5. That's what it is. F of whatever quantity that comes out from g of 1. F of whatever comes out of 1. Or f of, see, this is supposedly the output, okay, of g of 1. That's what it is. So we are expected to calculate a value. That's simply what it is. Okay. So we're still composing functions, right? F and g is being composed together. So for starting with inputs being x equals 1, being an input to 1, right there, the function g is the first function that takes 1 to now. So the rule of g says 2 times the input minus 5. 2 times the input minus 5. So that means that's 2 minus 5 is negative 3. So that means the function g takes this input 1 into the output minus 3. So now it actually becomes, in the next step, f of negative 3. All right. If anyone watching the video here feels I'm moving too fast, feel free to either roll back on the video or pause the video to see my explanation there. Okay. And now, in this way, now clearly this negative 3 came from the output of g at 1 or g of 1, but now it's acting as the input, as the updated input for our function f currently. So now we at the current point right here, at the current step right here, we're looking at evaluating f at negative 3 or f of negative 3, because negative 3 is g of 1. All right. So now in that way, we are looking at the rule of the function f says for every input minus 3. For every input, in this case negative 3, we're going to square the inputs minus 4 times the inputs. and plus 3. And now we are ready for the final evaluated answer. Okay, so in that way, okay, this is going to be, and now we can actually come up with a final answer here. So 9 plus 12 plus 3, okay, 9 plus 12 plus 3, so it comes out all together is 24 right there. All right, so that's how we're doing a problem like that. That's how we're doing a problem like that. But I specifically mentioned this. For you to understand the structure of the work. For you to understand the structure of the work right here. Okay, the structure of the work that, so now we've been doing the kind of problem where we directly substituting in expressions, and so maybe some student got so engaged into that kind of problem, and when all of a sudden we roll back to the easier kind of problem, we feel a little bit unfamiliar. Okay, but that's just simply how it works out. That's just simply how it works out. But then once you understand this philosophy, it will be brought into another brand new world of problems that are quite fascinating as well. Okay, and so now allow me to get anyone learning in this lesson here more comfortable with this kind of problem right here. So in that way, let me stay right here with these three functions. But now let's call that example 3. All right. So I'm going to say let f of x be this x squared minus 4x plus 3. Okay, and then g of x equals 2x minus 5, and then there's h of x equals 1 over x right there. Okay, so now let's evaluate, and simply just evaluate. So we just want to evaluate. So part A. Okay, so now we've done as the introduction problem an f of g of 1. So let's try again. So f of g of, how about 2? Okay, f of g of 2. Okay, so now let's just repeat what we've learned in that introduction problem right there. I am going to see this as f of g at 2. F of g, okay, but g is a function of 2. F of g of 2, or f of g at 2. That's what it is. Okay, and then from there on, that means f of, but now let's work from the inside out. Okay, let's work from the inside out. And so here's how it is. All right, so g of 2, the rule for g says we multiply every input. So in this case, the input is 2, but we multiply every input with 2. Okay, I should have written down the input first and apply the rule on top of that, like how I have been doing it. So the rule of g says for every input, we multiply that by 2, okay, and then minus 5 from it. And now that gives us, and so now this part right here, technically, I mean, once done, it's the output for g of 2. And that becomes f of minus 1, because 2 times 2 is a 4, minus 5 is a negative 1. But see, this is the output of g of 2. It's the output of g of 2, but now that output of g of 2 is acting as the input of f right here. Okay, so now once we are down to this point right here, then the instruction is still in front of us right here. It's indicating that I'm going to evaluate the function f here at x equals negative 1. All right, so now the rule of f says at whatever input that is, I'm going to square the input minus 4 times the input plus 3. Okay, and that now gives me, so that is a positive 1, a positive 5, another, positive 4 right here, and another positive 3 right there. So altogether is an 8. Okay, that's how I'm seeing it. All right, so that's the final evaluated answer right there. And that's why for this problem, we don't even have a variable at the end, so we didn't have to simplify it. We just go ahead and proceed all the way to the end of our calculation work right there. Okay, all right, so before I'm moving on to the next problem, let's observe here and let me make it now. So I started to say more and more the reasoning about inside out, working from the inside out. So in this way, right at this step right here, let me extract it out and focus your attention to this point right here. If we're looking at from the inside out, then this is the innermost. This is level 1 right here. That's what my number 1 is for. And this is my step 2, is to evaluate that. And then the step 3 is right here. Okay? And so now in that way, think about the order of how it works. So in step 1 right here, we go from x equals 2. The function g, okay, is going to take that to the function g. See, so g of 2 is going to take that input, because with that input from the innermost step right here, okay, so this is step 1. Step 1 for a given x equals 2. Through the function g, right, g takes 2 into a value, a new value being, we came out to -1. Okay, to -1. All right, and so now the function f, and this is step 2 right here. Okay, that's level 2 right there. So the function f through the function f, okay, it's going to take us to that final answer being 8. And so and calling that the step is not really the proper way of saying that, but this is sort of like the level 1 right here, and this is level 2 right here. All right, level 2, and this is the level 3 right there. Okay, that's where we arrive at the final output. Okay, and that's from the inside out there. All right, and so now let's do another problem. So here, just another way of explaining. So we use the rule of g to take 2, x equals 2 into -1. And we use a rule of f right here to take -1, which was the output for g. But now we take f here takes -1 as the input and bring that to the output being 8. So our final here is 8. Okay. All right. So now with that understanding, let's try a couple more problems here. Let's now look at part B. All right, so how about let's look at h of f, okay, at -1. Okay, h of f at -1. H of f at -1. All right, and so in the way how it reads, h of f at -1. So this -1 right here is the starting input, like that chart I drew earlier. Okay, so -1 is the starting input. So that means in the way how it works right here, the order is gonna take from the inside out, like that. All right, so here I see f of -1 first. So let's take care of what f of -1 is. So that means it's h of, the rule of the function f says for whatever input, because right now -1 is the input of the function f. So for every input of f, the rule says we're going to square the input minus 4 times the input, okay, plus 3. All right. Square the inputs minus 4 times the inputs plus 3. All right, so that means it gives me an output here. So for just f of -1, it gives me an output at the end being 8. So h of 8. Okay. So now this h of 8 now it is this 8 right here. So h of 8 now is going to be the final answer that we're looking for. But 8 itself right here, which came from the output of f, now becomes the input for h. So 8 is the output for f, but now it's being the input for h. Okay, and so now the rule of h, now according to this notation, the rule of h says it's 1 over whatever input that is. Okay, which is simply a 1/8. Okay, so that's how we're doing these kind of problems like that. All right, so that is, and so you can start right here. I can give, right in this example 3 right here, I can put in an FYT right here for you to try independently. Okay, so let's look at g of f, okay, of 0. G of f of 0. Okay. All right, so go ahead and spend some time. You can pause the video and work through the problem right there. And when you believe you're done, I will proceed. All right, so at this point, I hope you have spent enough time after pausing the video and spend enough time working with that. Okay, the answer here would come out being +1. All right, simply that is the answer. And since this is an FYT, I would like you to just simply compare with my answer, but you should have had your explanation in your own work, your steps written down in your own work. All right, and so that is now the end of our example 3 right there. But so I brought up this example 3, and I brought up this kind of problem for a reason. I even introduced that. I introduced you before getting to the kind of problem before getting into example 3. Okay, because now once we have a general, even more, so this kind of problem generalized your understanding about the composing function. Okay, about the composition of functions. And so now let's get into another kind of problem where I call that example 4 right here. All right, so let's now call that example 4. Let f of x and g of x be given as or be defined or be represented, okay, by the given graphs. Okay, so now you are given graphs like that. And so now I'm going to have a little more note right here, just a little notes right here, but f of x is in red, and I haven't shown the graph yet, okay? And g of x is blue, even though I don't have the blue marker, so allow me to write blue, but in black ink. All right, so now let me show the graph, okay? Let me show the graph, and then I will write down the actual problem. All right, so this is now the graph for the two functions. So as indicated earlier, the graph in red right here is the graph of our function f of x, and the graph in blue right here is the graph for g of x, just as indicated here. So f of x is red and g of x is blue. So now I put that there, and let's now, so again I'm using Desmos for any of these graphical illustration right here. So let's just, Desmos is powerful enough so that I can put in a special couple points right here, because well, the grids are already making it easy to recognize the input and the output values, and at this point anyone is expected to be fluent in terms of reading graphs. Okay, so the grids are making it easy to read and identify these input and output values already. But for for assistance, for good assistance for the viewers. So I'm gonna go ahead and turn on the actual labels of those a few special points like that. Okay, on this graph. All right, but now from that point, so let me just simply put that in full view for anyone to, in case anyone need to take notes or anything like that. And so now we are ready for the first question. And let me also still retain that on the corner of our screen here. But let's say now part A of the example 4 here. Let's look at, so now I'm going to look at, how about f of g, okay, of, how about 1, okay, f of g of 1. All right, so f of g of 1. So in the way how it is right now, and just from that example and the problem I brought up before, even before example 3 right there, then first we need to understand what this tells us to do. We have to understand what this is trying to communicate with us, okay? So a lot of time in math, it's all about we have to read the symbols properly so that we have a clear understanding of what the problem is indicating for us to do. So here it's indicating that the problem is looking for, see, and I was saying it out loud earlier, f of g at 1, or of 1. So that means it's f of g, okay? And now a little more specifically, of 1. All right. So in this case, just the exact same argument as we've had before. Now we have to work from the inside out, So now at the innermost level, then we're looking at that input being x equals 1. Okay, x equals 1, but then we first have to find out from the inside out the output of g at 1 first. Okay, and so now at this point, the only way to determine the output of g at 1, the only output, and I did not write this down particularly, but it really means evaluate, but in the case we have a graph like this, it just simply means we're estimating. Everything here exists as an estimation. So g of 1, now I'm going to use the graph to estimate the output value of g of 1. Okay, so on the graph here, now let me put the graph in closer zoom right here, in full screen zoom, then g of 1. So now about x equals 1 is right here. G of 1 is the blue curve. Okay. So now in that way that we recognized the graph of g, the blue graph, vertically sank down to as low as y value being negative 1, as observed through the graph right there. Okay, and one more time, let me put it back in full screen view right here. So when x equals 1, g of 1, okay, g of 1 equals a negative 1 as indicated with the graph right here. Okay, so in that way, now I have an answer. Well, we're getting somewhere. So I now have an output for g of 1. So that means in the next step, I'm looking at f of, but now the output of g of 1 is indicating that it's negative 1. So now I'm looking at f of negative 1. And so allow me to start writing that in blue ink right here. Okay. So now since I was just now graph a blue marker, so allow me to write this blue. Okay. So the graph for g of x is in blue and the graph for f of x is in red. And so now the outputs that came out according to the blue graph, it sank down to the y value, to the vertical value being negative 1. So this is the output from g of 1. All right. And now in that way, so now f of negative 1. So now I'm going to start looking at the red curve. Okay. So at this point, I'm going to focus on the red curve right here. And now I'm going to use a red ink. Okay. So red curve right here. Now let's put our graphs. So now we're no longer looking for f at 1, but we're indeed looking for f of negative 1. So f at negative 1 seems like about down here right here. Okay, so f at negative 1. And so f at negative 1, all right, so we're estimating that it's about the negative 1 as well. Because where I put the point about right there, see, with the label that just popped out in a fainted print right here, negative 1 comma negative 1, that's popping out. All right, so in that way now I'm ready to say out the answer, the final output right here. This overall answer is a -1. So it looks a little odd that I'm writing the answer in red ink right there, but it's indicating that this is the final outcome that came out from the red function. Okay, we use a red function to indicate that. All right, so this problem here demonstrates the idea of how we can work with composition of two functions, and we can track down the output based on the graph, the given graph right there. Okay, so now let's get through a few more problems here. So it was intended to be an evaluation problem, but again, as I said, graphing is the graphs given here is the only choice that we have, and so really the best we could do was to estimate all of these values. So these all came out from as estimates. Okay, so now I'm going to call that part B of our example. All right, so for part B, and now we can look at what about g of f. Okay, and I'm saying it out loud right there, g of f, and I'm going to pick a value randomly. How about 0, g of f at 0, okay, or g of f at 0. All right, so in this way, how the symbol is indicating, and that means the indication here means we're looking for g of f, as I was saying out loud often enough up to this point. G of f of 0. So the innermost level right here is the x equals 0 as the input. So this value right here we're going to be looking for looking for x input on the horizontal line. Okay. But now I'm going to need to use the red function. So this value here is going to come out in red ink right here. Okay. And so now let's look for that. I'm going to put the graph in full screen view right here. All right. So when x equals 0, with our red function being found right here, okay, and even though the point is not indicated here with the software, but we still have a point right there. So 0, 1. So when x equals 0, our f of 0 equals 1, which is indicated right there. All right, so in that way, now I have an answer for f of 0. That means in my next step, I'm looking at the following. So now g of, okay, and now it's g of 1, because this one here came out as the output of f of 0. Okay, and again, we're working from the inside out. See, we found that function value, that output of the inside function first, and then the output of the inside function becomes the input of the outer function, and we keep working that from the inside out and keep going further out and further out. All right, so now it's clearly g at 1, or g of 1. Okay, so now to look up for the output value of g of 1, now I'm going to start looking at the blue graph right here. All right, so again, putting my graph in full screen view right here. The g function this time is this blue curve right here, and g of 1 is right here. Okay, and it's right about that point right there. So g of 1. So the value came down to as low as -1. All right, so in that way, clearly I'm looking at equal. Okay, so we have an equal value. We have a value right here, and that sinks down to as low as -1. So this time allow me to write the final value in blue ink right here, to indicate I obtained this value with the final function here in the blue graph. Okay, represented by the blue graph. All right, so that's how it works. Okay, that's how these problems work. I mean, it's just that concept about composing a function. I mean, a concept of the composition of two functions, and then we use the graph to estimate these outputs value, and then the output value of the inner function becomes the input value of the outer function, and so on. We can just keep tracking it down. All right, so let's continue based on just the graphs given here. Let's continue challenging ourselves with some more problems, and let's now allow the problems to become more and more challenging. Okay. So now I'm going to call that part C of the example. So at least throughout this lecture here, I haven't repeated this kind of problem for a little while already. So what about part C right here. Let's do f of f, okay? F circle f, or f of f. All right, so f of f of 2. Or as a matter of fact, let's change this to about just 5. All right. And so f of 5. All right, so now here's how I see it. This means, this symbol at start means we're looking at f of f. And that's the way how it was saying f of 5. That's how this is how I understand about this notation. Okay, and now once we have set down that foundation for our work right here, then we're going to be working from the inside out. So that means from at the innermost level right here, we're starting out with an input on the x-axis. So this is going to be found on the x-axis. And then I'm going to use my, see, it's f of x right here. I mean, it's the function f. So I'm going to be using my red curve to decide, to determine, or at least what we can do is to estimate the output value of f of 5. Okay, and so now, let me now put the graph in complete full view, full screen view right here. So the function f is here, okay, and f of 5 is this height right here. F of 5 is this height. All right, so now with f of 5 being this height right here, then so the y value, the vertical value for that particular point is 3, about estimated. And gladly the graph had these points with the labels for us, making it a little easier for us here. So that's how it is. But in case we didn't even have these labels and we just read right from the grids, that should be good enough. Okay, so now in that way, now just allow me to underline that I need to use the red curve to determine that value. But then for the rest, you know, anytime we come out with an answer, I'm too tired of switching the color around. So I'll just go with that becomes f of 3. Okay, that becomes f of 3. And then again to the answer, the output of the earlier inner function now becomes the input of the outer function, which is still f. So g or f is just the rule. And in this problem here, the rule is described by the graphs. Okay, any of the rules is described by the graph. And so now all we see is we use the graph to determine the output. Okay, so now I'm going to need to use the red curve again because it's f of 3. But now 3 is being regarded as the input for this current work. So once again, back to full screen view right here of our graphs right here. Then when x equals 3, okay, it didn't have a specific point, but it's at least in this portion of the graph in red right here, it's a constant function. So it must be this same height. So it's going to be the vertical value is about 3 grids up right there. So it should be 3 being the output right there as well. Okay, so in this way, now I have come to the final answer. F of 3 in this case, according to this graph in red, is 3. And that's my final answer for that. At least it's an estimate for that. All right, so let's try another one. All right, so now let me look at part D of the example. Okay, so part D of the example, how about let's do f of g of g, okay, at 0, okay, f of g. So 3 functions being composed together, or it's a composition of 3 functions together. Okay, let's find out how it works. Okay. So you should be at this point fluent enough to see what this is indicating for us. So just right from that way of reading the indication right here, let's just set down for ourselves the foundation of where we can go from here. So it's f from the outside in. When we're laying down and we're going to write it from the outside in, f of, okay, of what? Of g of g, okay, again, okay, and then inside of that at 0. All right, f of g of 0. All right, and so now in that way I am going to start. So now when we're evaluating it, then we're going from the inside to out. So at the innermost, I have an input here where on the x-axis it stays right at the origin right here. That's the x-axis, okay? And let me again switch that back to full screen view right here. So when x equals 0, but now at this level I'm going to be using my blue function because it's g. So we have to start out nailing down g function first. It's just the way how this problem is set up. Okay, so I have to go with the blue graph. Okay, that's where I put that blue brackets here with me. Okay, so blue graph here on the blue graph, when x equals 0, when input equals 0, the output for the blue graph is. So now in my next step, I'm still gonna write down the f. Okay. F of g of, but now I'm ready for throwing in some value here, which would be the outputs coming out from g of 0. Okay, so now on the graph here with the blue curve, g of 0 equals 0. Okay, the point was not given a label with decimals here, but it's clear enough that we can estimate it equals 0. All right. So in that way, now I have an answer. So this in the next step, this is equal to f of g of 0, because hey, this 0 here came out as the output that's estimated from g of 0 here. All right, and now again, I'm still looking at, and we're still working from the inside out. So now I'm seeing that now our next responsibility is to evaluate g at 0. And once again, function g is the blue curve. Okay, and that's why I'm underlining that with a blue marker right here. And then again on the graph right here, g of 0 with the blue curve, g of 0 is 0 right there. Okay, 0, 0. All right, I put that point there. And so now in that way, the next outputs. So this g of 0 will give me the output being 0. But then with that 0 here, it's now going to become the input for our function f. And this time here, we are going to use our red function to obtain or to estimate the final output. So it's red at this level right here. Okay, and it depends on the way how the problem was given. All right, so now back to full screen view right here. F of 0, this is f right here. When x equals 0, the output value came out to be about 1 right there. At least that's what decimals estimated for me. All right, so now we have a clear answer. The answer now is equal 1, or at least estimated to be 1. That's how we've had this problem done right there. All right, so I would like to just enforce your understanding about composition of functions. Now we're even in that case where we evaluate a value through the graphs right here, and one graph generate a value, and that value becomes the inputs for another graph. I mean, that's for another function where we're going to use the graph for the outer function, right, to obtain the output value, and eventually we reach our final answer. Okay, and that's how it has been done throughout these the example right here. All right, so I gave about 4 problems, and it's impossible for me to cover all kinds of problems, but I hope you have already seen some generality of this kind of problem right there. All right, so let's now move on to the next example. And now I no longer need the graph, so I'm going to put the graphs away. All right, so let's call that now example 5 right here. All right, and now we're looking at, I'm going to let f of x, okay, and g of x be represented, okay, very similar to the earlier example, be represented as the given tables, okay, tables of values below. Okay, so now we're working with tables. All right, and so now we just simply want to evaluate. Okay, let's simply want to evaluate part A, and actually now I'm gonna make some space to show the table, and then before I write in the actual the instruction of the problem, which you kind of seen that you have kind of seen that already. All right, so this is our table now. Right, so technically we have two tables, but allow me to come up with a creative way of writing the table. So it's going to be one column for x. So technically it's two tables, so that's why I said it's tables, right? But now I'm going to combine it in one table with three columns. But it's 1, 2, 3, 4, 5. Okay, with a table like that, one column is for the input. Okay, and now I'm going to have a column that indicates, that specifies the output values for my function f of x. Okay, which gives me 6, 8, 3, and 1. Okay, and indeed I made my table a little too long, but we don't need to have that input, that x value for 5. Okay, so we don't have x equals 5 on this table. And then g, I'm going to have another column for g. Okay, so that means both f of x and g of x use the same column right here, use these same input values. Okay, so now I'm looking at 3, 5, 2, 7. All right, 3, 5, 2, and 7. Okay, and so now that's the idea of the table. And so again, just due to the nature that I'm having very narrow space here, I'm gonna combine two tables into one. But really, it's one table for x and f of x, and then another table for x and g of x. Okay, so now from that table we want to evaluate. Okay, we want to evaluate. All right, we want to evaluate, and now I'm gonna move over to the other part of the board, or maybe let me also write this instruction on the other board right there. All right, so part A, or to continue, we just want to evaluate. All right, and part A, right, from the table I want to evaluate. How about f of g of 1? But the way how I'm writing that, f of g of 1. Okay, f of g of 1. All right, so again, just like how I have done in the graphing problem in example 4, and just like how I've done it back in example 3, and even including that example back in that little introduction problem before getting into example 3, then the way how I want anyone to see this problem is that this is exactly f of, and I was saying it out loud that way, f of g of 1. That's how it is. And so we're going to be determining the values, the output values from the inside out, Okay? The only thing different in this example compared to earlier example is that we're completely based on the table. We're using the given tables for that. So from the inside out, g of 1, we have to start tackling this down first. G of 1, what's the output for g of 1? So in this kind of problem, since we're not looking at graph, but instead we're looking at table. Any table has already given us solid value. So these problems are truly a problem where any of one of these problems is a problem where we truly evaluate the final outputs. Whatever is given on the table is an exact value. Okay, because whatever that rule is, it gives us these exact output value. So it's going to be f of. Okay, but let's look it up for the value, the output value of g when x equals 1, when the input equals 1. Okay, so now, all right, so when input equals 1, g of 1 That's why reading the table right here, and when x equals 1, g of 1 equals 3. So this is the output for g of 1 right there. All right. So now I'm going to go ahead and write that output of g here. But that now becomes f of 3 for our next step. Okay, so now 3 here, which was the output of g of 1, but now is playing in a role of the input for our function f. All right, so now I'm going to use a table again, but this time the table for f, for the function f, to look for the output value, to determine the output values. Okay, so now back on the other board right there. So now when the input equals 3, my output value for f is also 3. Okay, so that is what that is right here. So this is going to be the final answer for our work right there. Okay. All right, so that final answer here is 3. And that is how we have done the part A of the example. Okay, and so let's now look at part B to give it another try right here. To give it another try. All right, so now how about g of f of 4. Okay, so g of f of 4. All right, so with this symbol right here, it reads, so what it reads here is that, what it's indicating here is that we want g of f of 4. G of f of 4. Okay, and so now we have to again work from the inside out. So the inner function here is going to be the function f at our starting point. But then f is going to take input 4. Okay, so now I'm going to use a table for the table values for f of x to determine the output for f of 4. Okay, so in the next step, I'm going to write g of, but I'm waiting for a value, the output value that whichever that comes out from f of 4. So we're going to swing back to the table right now. All right, so now with the table, when the input here is 4, the output for f here is 1. Okay, so now I'm going to use this value and put it in the empty parentheses there. So that becomes g of 1. That's what it is right there. All right, and so now in this current step right here, it's entirely a problem where we want to evaluate the outputs of g based on the inputs being 1. So this 1 right here was the output of f of 4, but now it's once we have successfully calculated that and came out with this particular numerical value, it is now the input value for g. But then we are no longer using the function f, we're using the table for function g. And that now is going to give me, okay, so in this table, when the input is 1, the output is going to be 3. Okay, so in that way, we come to the final answer here being 3 for that. All right, and so now this kind of problem, it's easy enough, so I don't think we need to go any further. But for your own trying, how about you can do the following problem for your trying right there, an FYT for your trying, like that. So how about I want anyone to try f of g, okay, of 3. All right, so go ahead and spend some time doing that. And then you can always pause the video, and once you're ready to resume the video, I'll jump in and give my final answer. All right, so the final answers for this, and I'm going to leave all the explanations out because you have seen all the explanations through the steps already. The final answer for this is going to be 8. All right, so that is how we get it done like that. Okay.